In the previous video, we discussed the trends in the periodic table with reference to the atomic size. We learned that moving left to right across a period, the atomic size generally decreases. This is because as we move across the period, the nuclear charge of each atom increases by one proton, and thus the effective nuclear charge experienced by the valence electrons increases, which in turn reduces the size or the atomic radius of the atom. But when we move down the group, the total number of energy levels or shells increases, which increases the size of the atom. The effective nuclear charge remains constant down the group and does not play a role in this regard. Now let's solve some problems. So let's look at which atom is bigger, calcium or magnesium. Now we know that these two elements both belong in group 2 and magnesium lies above calcium. Now to confirm, magnesium has atomic number 12 while calcium has atomic number 20. So when we go down the group, the atomic radius increases. That is why we can surely say that the atomic radius of calcium is greater than that of magnesium. To confirm, you can also write the electronic configuration of magnesium and calcium and infer with the number of shells. Now to put some numbers into practice, empirically, the atomic radius of magnesium is 160 picometer, while that of calcium is 197 picometer. So we know from empirical evidence as well that our prediction that calcium is bigger than magnesium is correct. Now let's look at the second example. Which atom is larger, silicon or phosphorus? To understand where they are placed in the periodic table, let's just look at their atomic numbers. Silicon has the atomic number 14, while phosphorus has the atomic number 15, which means that silicon is on the left of phosphorus and they are members of the same period. We know that as we move from left to right across a period, the atomic radius decreases. So we should expect that silicon should be bigger than phosphorus, because we know that the number of shells that these atoms have are the same, but the effective nuclear charge increases as you move across the period. So that brings us to the conclusion that atomic radius of silicon should be greater than that of phosphorus. Now, to check this theory with practical evidence, we know from empirical evidences that the atomic radius of silicon is 117 picometers, while that of phosphorus is 110 picometers. So our prediction stands correct. Now what about strontium versus sulfur? Which one's bigger? So strontium is an alkaline earth metal and sulfur is somewhere towards the right and basically above strontium. Now atoms get bigger as you go down and as you go to the left. They get small as you go to the right across the period. So basically, atomic size increases in this general direction. So we should expect that strontium should be a lot bigger than sulfur. The atomic radius of strontium is 215 picometers and for sulfur is 104 picometers. So the atomic radius of strontium is twice as that of sulfur. So strontium is definitely bigger than sulfur. Now let's look at an example with multiple elements. Arrange the following elements in the increasing order of their atomic radii. The atoms in question are oxygen, carbon, fluorine, bromine, and chlorine. Now before we delve into this question, let's recall what we know. We know that the atomic radius increases down the group and the atomic radius decreases across the period, moving from left to right. So now to examine the elements we have. We can see that oxygen, carbon, and fluorine are members of the same period, while fluorine, bromine, and chlorine belong to the same group. So clearly, The largest atom in question is bromine, which is in the fourth period, followed by chlorine, which is in the third period. Now we are left with oxygen, carbon, and fluorine, which are the members of the same period. And we know that the atomic radius decreases across the period. So fluorine should have the least radius here, belonging to group 17, and carbon should have the largest radius among the three. So oxygen ends up sandwiched between the two with intermediate atomic radius. So that's it for now. Happy learning!